Imagine a bustling city. Each district has a unique function, operating independently yet interconnected. This is the essence of microservices architecture. It's about breaking down a large application into smaller, independent services. Each service focuses on one specific functionality. These services communicate with each other through APIs, much like independent entities working together. This modular approach offers flexibility, scalability, and resilience. Think of a traditional monolithic application as a single, large machine. If one part breaks, the entire system fails. Microservices, however, are like separate modules. If one module malfunctions, the others remain unaffected. This isolation enhances fault tolerance and simplifies maintenance. Developers can update or fix individual services without impacting the entire system. Let's consider an e-commerce website. In a monolithic architecture, the website, order processing, and payment gateway are tightly coupled. With microservices, each function becomes an independent service. This allows for easier scaling, faster development cycles, and independent deployments. Each service can be developed, deployed, and scaled independently, catering to specific business needs. In essence, microservices architecture promotes agility and resilience in software development. This approach is particularly beneficial for complex applications with evolving requirements, allowing businesses to adapt quickly to changing market demands. Microservices offer a compelling alternative to traditional monolithic architectures. This approach brings numerous advantages, transforming how we design, develop, and deploy software. Let's explore some key benefits in detail. One significant advantage is improved agility. Each microservice can be developed and deployed independently. This allows teams to work on different services simultaneously, accelerating development cycles. Teams can use different technologies for different services, choosing the best tool for each task. This flexibility fosters innovation and allows for faster adaptation to new technologies. Scalability is another key advantage. As demand for specific functionalities grows, individual microservices can be scaled independently. This targeted scaling optimizes resource utilization. It also reduces costs compared to scaling an entire monolithic application. This granular approach ensures optimal performance even during peak loads. Microservices also enhance fault tolerance. Since services are isolated, the failure of one service doesn't impact others. This isolation prevents cascading failures and improves the overall system's resilience. This independent nature allows for easier debugging and faster recovery from failures. Furthermore, microservices promote technology diversity. Teams can choose the most suitable technology for each service. This flexibility allows developers to leverage the strengths of different programming languages and frameworks. For instance, one service can be written in Java for its robustness, while another can be in Node.js for its speed. In conclusion, microservices offer a range of benefits that streamline development, enhance scalability, and improve resilience. This architectural style empowers businesses to respond rapidly to changing market demands and deliver value to customers more efficiently. While monolithic architecture served its purpose, its limitations became increasingly apparent as applications grew in complexity. Microservices emerged as a solution, addressing these challenges and paving the way for more scalable and maintainable systems. One major problem microservices solve is the scalability limitations of monolithic applications. In a monolithic structure, scaling requires deploying the entire application multiple times. This approach is resource-intensive and inefficient. Microservices, however, allow for independent scaling of specific functionalities. This targeted approach ensures optimal resource utilization and cost-effectiveness. Another challenge is the slow and cumbersome deployment process associated with monolithic systems. Even a minor code change necessitates redeploying the entire application. This process is time-consuming and increases the risk of errors. With microservices, developers can deploy individual services independently, accelerating the deployment cycle and minimizing disruption. Monolithic applications often suffer from limited technology flexibility. Adopting new technologies or frameworks usually means rewriting the entire application. Microservices break free from this constraint. Each service can be developed using different technologies, allowing developers to choose the best tool for each task and embrace innovation. Furthermore, microservices address the single point of failure issue inherent in monolithic systems. One error in a monolithic application can bring down the entire system. Microservices' isolated nature ensures that a failure in one service doesn't impact others, enhancing fault tolerance and system resilience. In essence, microservices offer a more agile, scalable, and resilient alternative to monolithic architecture. This approach addresses the growing pains of complex applications, enabling businesses to adapt quickly, scale efficiently, and deliver reliable software solutions.